It's so exciting watching my life unfurl at a time when geeks like me can change the world. There's a hackathon tonight, and if it works out alright, I can improve society. Oh yeah, improve society. A VC will be there with money in his wallet. If I pitch him like a boss, I could get money for my project. 7-figure sum, and I'll be crushing everyone at the hackathon tonight. At the hackathon tonight. Yeah, the prize is up for grabs if I can get paid. My phone is 6 months old, you know I need to upgrade. I can surely waste some gadgets if I sweet talk with the judges at the hackathon tonight. At the hackathon tonight. Now the rebel's on the table and I'm ready to go. I've got Sublime 5 open on my MacBook Pro. I'll type in 20 words a minute. I'm really gonna kill it at the hackathon tonight. At the hackathon tonight. The buzz is gone, we're underway, my chance to shine has come. The cable mess around me shows I'm hacker number one. The framework that I'm using's not in alpha yet. I'm coding on the bleeding edge, we're starting to regret. Just to set up the environment is taking so much time. The clock is ticking down, I haven't written a single line. The Wi-Fi's cutting out, I've got a dying battery. I got conflict after conflict in my Git repository. The deadline is approaching and there's still a bug to mend, but my code is obfuscated. Will this nightmare never end? My time ran out and I had to stop. Instead of showing a demo, I used Photoshop. I tried to change society, but it wasn't to be. At the hackathon tonight, oh yeah, the hackathon tonight.
Welcome, everyone. Thank you so much for coming. Welcome to our very special HACKTOBERFEST series. I would first like to wish you all very happy HACKTOBERFEST and welcome to our IBM and SiB Solutions Enable Flawless Logistics with IBM Code Engine series. So this is part 2 of our series. If you weren't able to attend part 1 and you're joining from Crowdcast, you can actually view and watch the live stream recording playback at the top of the screen where it says session 2 of 2 at the top. You can actually click on that and view the first session as well. So enable flawless logistics, it sounds very fancy, but it's we're going to be doing a workshop today with SiB Solutions, which is one of our IBM partners, and they are a logistics company based in Sweden. So we're going to talk a little bit about them in just a minute when we get started. But for to go over housekeeping, if you're joining in Crowdcast, all of the resources that you will need are at the top of the chat. If you are joining from any of our IBM developer social channels, I will share all of the links that you will need to get started and follow along with us. So first is the slides. Everything that we'll be sharing here today is available in the slides at ibm.biz/ce-sib-slides. So everything we're going to be going over today, as well as from yesterday, is all within the slides at the link here. Yes, this session is being recorded. You can access the live stream recording after the session has ended at any point in time at crowdcast.io/e/IBM-CE-SIB/2. So if you're joining from Crowdcast, you'll be joining with the same URL that you joined with today. If you're at any of our IBM developer social channels connecting with us, the live stream recording will live at the Crowdcast link here. And lastly, if you would like to follow along, you will need an IBM Cloud account. And you can sign up for one at ibm-biz/ce-sib-2-cloud. So the repository for the workshop today lives at github.com/jwritten/IBM-X-SIB. So once we have V2 of the workshop fleshed out, we will be adding the workshop tutorial to our other IBM developer resources, as well as to the Code Engine repository as well. But right now, you can access it here. So if you haven't already, go ahead and share in the chat your name and pronouns, where you're joining from today. If you're comfortable, your title and maybe what company you're working for or what program you're currently studying in. If you're currently studying at the moment, something you love, and a quirk, so something that's uniquely weird or different about you. So I will go first, and then I will pass over to SiB Solutions to introduce themselves as well. So my name is Jenna Ritten. My pronouns are she, her. I'm a cloud developer advocate at IBM. I am originally from and currently joining from Detroit, Michigan. Something I love are my dogs. I have 3 little Yorkies. Luckily, they're quiet. They're quiet right now. I think I have them contained this time. And let's see, a quirk. So if you've joined any of my sessions before, I always go with the same thing. I have an obsession with tuna melts and tuna salad sandwiches. So if you have any recommendations, please feel free to share them with me on any of my social platforms, at jwritten on all social media platforms. And if you need to follow up with me, ask any questions, book some time with me, check out any of my other workshops and any of my other tutorials and content, you can do that at linktree/jwritten. So I'm going to pass things over to SiB Solutions. They can introduce themselves and tell you a little bit more about them.
Yeah, hello everyone. My name is Sverrir Valgeirsson and I'm the CTO at SiB Solutions. And something about me. Well, I'm extremely much a nerd, and I've always been a nerd from starting with C64 and Amigas and FreeBSD and stuff like that, and working with ASICs and software development and anything like that. So, well, maybe a little bit boring, but yeah, programming and making stuff with computers, that's my thing. And quirky or different, well, I make music as well. That I do too. Yeah, a bunch of cats around that can definitely disturb this if they feel like they're being neglected, but I hope not. And I work at SiB Solutions, as I was saying. We are a logistics technology company. We use AI and video to help logistic businesses with flawless logistics, making their logistics flawless. So that's what we do.
Thank you so much. And I think too, before we jump into the workshop, after we do a little high-level overview, I'll pass back to you so you can tell a little bit more about what it is that you guys do. And before we jump into the workshop, where we're going to do a very simple demo of working with the similar type of technologies. Okay. So before we jump in, one thing I always like to share are the IBM Cloud certifications. So one thing that I personally really appreciate is being able to get certifications to upskill your technical skills, especially when they're for free. Actually, there's a comment in the chat. So Michael, if you're having any trouble with your audio, and to anyone watching, if you're having any issues hearing or seeing anything at any point in time, go ahead and refresh your browser, and that should clear up any issues you might be having with Crowdcast. Okay, so okay. So these are some of the IBM Cloud free certifications that I've personally chosen for all of you. These are certifications that I've personally worked through myself. I would highly recommend, especially in the spirit of HACKTOBERFEST and everyone learning, getting their hands dirty, trying new tech stacks. It was everything from getting really familiar and hands-on with Docker to building your first cloud-native applications. So I'd highly recommend if you have time. They don't take very much time. So I was working on I think a badge a day last summer, just trying to see how many I could get through. The links and everything are in the slides as well. And I would like to take just a second to welcome you all to join Call for Code as they celebrate the end of HACKTOBERFEST with a demo day. So you can join to celebrate and review the progress the community has made and find out more about how you can get involved as well. So there's a registration link that I'm going to share in the chat for you, but you can register at ibm.biz/demo day. There we go. Okay, so let's go ahead and get started. So the agenda for today, some things we're going to cover, kind of how our morning's going to go here over the next hour. We're going to talk about what is a container. We're going to cover container images and container registries. We're going to talk a little bit about serverless. We're going to talk about Kafka and event streams. And then we're going to talk about Code Engine and how all of these things come together. And then we're going to get to our hands-on portion of the workshop, where we're going to be using event streams and Code Engine to build a Python Kafka live streaming application, very simple application using event streams, and we're going to deploy it to Code Engine. Okay, so first of all, what is a container? So a container is just a standard unit of software. It's a package of executable code, including all of its dependencies that are required in order for the application to run quickly and reliably from one computing environment to another. Containers can run on Linux, Windows-based, Windows operating system, Mac operating system. So the nice part about containers is that the containerized software is always going to run the same, regardless of the underlying infrastructure or what operating systems you might be running your applications on. And it's able to do this because containers isolate software from its environment, and they ensure that it works the same despite any differences, for instance, between development and staging, if you're at a company. Okay, so as you can see here, we have a virtualization and we have our containers here. So our containers are running on top of our host operating system, and each container is includes all of the application runtime supporting files, any environment requirements, system tools, libraries, things like that. So if that's what a container is, then what is a container image, right? So a lot of times you'll hear these terms used together. because when we're working with containers and container images, we're working with both of them. So a container image is a lightweight standalone executable package of software that includes everything you need to run an application, including the code, runtime, system tools, system libraries, and any settings. And you may be saying to yourself, well, isn't that the same thing as a container? So the takeaway here is that, yes, they contain the same standalone executable package of software. Container images actually become containers at runtime. So the takeaway here is as soon as we run the Docker images that we're going to be creating today, those images are going to become containers when we run them locally on Docker or when we deploy them to Code Engine. So those container images are going to become containers at runtime. Now, since we're talking about Docker, what is a container registry? So that's something we're going to take a look at today as well. So when we're working with container images, we need to store them somewhere, just like we do our code in repositories. So registries act very similar as repositories, and it's a place to store container images, and you can share them through a process of uploading, which is referred to as pushing, and downloading, which is referred to as pulling. So in addition to container images, registries also store application programming interfaces, or API paths, and access control parameters. There's two types of container registries, public and private. Public registries are going to be great for, things like workshops and contributing to open source, personal projects, hackathon projects, and private registries are going to be a great way to incorporate added security and privacy into enterprise container image storage, and that can be hosted either remotely or on-prem. Private registries also come with advanced security features and technical support, and a great example of that is Red Hat's Quay. So IBM has a container registry as well called IBM Container Registry. Docker has a container registry called Docker Hub, and Red Hat has a container registry called Quay. So we're going to be working with Docker today. So when we're talking about serverless, because when we're talking about Code Engine, we're talking about serverless. So serverless is just a cloud execution model that enables simpler, more cost-effective way to build and operate cloud-native applications, like that we'll look at in just a minute. So serverless provisions computing resources on demand, and the great part about it is that it offloads all the responsibility for common infrastructure management tasks like scaling, scheduling, patching, and provisioning to cloud providers and tools, and allows developers to focus their time and efforts on business logic specific to their applications or process. So you can get back to getting hands-on, building out your applications, doing your work as a developer, and not having to manage or worry about any infrastructure. So a common misconception, are there servers in serverless computing? Yes, so there are servers in serverless computing. So the term serverless persists because it describes the customer's experience of serverless. They're essentially invisible because as a developer or as a customer, you don't see them, you don't manage them, and you don't have to interact them in any type of way. So because you as a startup or as an engineer working with serverless, you do not interact with the underlying infrastructure in any type of way. That's why they're referred to as serverless. So what is Kafka? So we're going to be working with this a little bit today. There we go. So Apache Kafka is an open source distributed streaming platform that enables the development of real-time event-driven applications. So an event is a digital record of an action that happened and the time that it happened. So typically an event is an action that drives another action as part of a process. So for instance, dealing with logistics, a customer placing an order or choosing a flight, choosing a seat on a flight, or submitting a registration form for some type of event. Those are all examples of events. And an event doesn't have to involve a person. So for example, a connected smart thermostat will report the temperature at any given time. That's also an event. So Kafka has three primary capabilities. It enables applications to publish or subscribe to data or event streams. It stores records accurately in the order in which they occurred in a fault-tolerant and durable way, and it processes records in real time as they occur. So we will be able to see this in action. We get to hands-on portion. And what is event streams? Because we're going to be working with event streams today. We're going to be provisioning an instance of IBM event streams. With IBM event streams, as a developer, you can leverage these Kafka capabilities that we just talked about through our 4 APIs. So what we have available with IBM event streams, we have a producer API that enables an application to publish a stream to a Kafka topic, which you will see. We will be creating a topic in just a few minutes. And a topic is a named log that stores the records in the order they occurred relative to one another. So after a record is written to a topic, it can't be altered or deleted. Instead, it remains in the topic for a pre-configured amount of time, which you will see when we create our topic. We will actually decide that as we're creating it. There's also the consumer API that enables an application to subscribe to one or more topics and ingest and process the stream stored in the topic. So it can work with records in the topic in real time, or it can ingest and process past records. Now, today, we are going to be working with event streams, and we are going to be working with the producer and consumer APIs. There is also the streams API, and that builds on the producer and consumer APIs, and it adds a more complex processing capabilities that enable applications to perform continuous front-to-back streaming processing. So specifically to consume records from one or more topics, to analyze or aggregate or transform them as required, and then publish the resulting stream to the same topic or other topics. So Streams API enables development of more sophisticated data and event streaming applications. And then finally, we have the connector API. So this lets developers build connectors, which are reusable producers or consumers that simplify and automate integration of data sources into a Kafka cluster. There we go. So what is Code Engine? So we've talked a lot about serverless and Kafka and event streams. So IBM Cloud Code Engine is IBM's fully managed serverless platform as a service that runs your containerized workloads for you. This includes web applications, microservices, event-driven functions, or batch jobs. Another feature of Code Engine that we won't be exploring today, but if you have joined or want to check out the Code Engine 101 and 201 workshop series, we utilize Code Engine's source to image feature. So Code Engine will build container images for you from your source code. All you need to do is add a Docker file to your source code, and Code Engine will build your container image for you using source to image feature. So some features of Code Engine is, as we mentioned, it can host any containerized workload in the cloud. So if it's a if it has a Docker file, or it's already a container image, it can run your workloads for you in the cloud in just a matter of seconds, as you'll see in just a few minutes. So this includes web applications, microservices, functions, and batch jobs. It also can auto scale up and down, even to 0 when idle. So we'll be looking at an example of that as well. As we mentioned before, as this is a serverless platform as a service, it hides all of the infrastructure. So manages, scales, secure clusters, networks. It's doing all of this under the hood. So you don't need to have any expertise or background knowledge in containers or Kubernetes or infrastructure. You can just focus on writing your code as a developer and building out your applications. It also builds container images from source code, as I mentioned, from public and private repos and registries. So any repositories or registries where you store your code, Code Engine can run that for you. It's integrated into IBM Cloud and all of IBM Cloud services, and it's built on open source software, Kubernetes, Knative, Istio, and Tekton. So it's keeping your portables, it's keeping your workloads light and portable. And the best part is you pay only for what you use. So if your applications are not receiving incoming HTTP requests, you're not paying for provisioning for applications that are not receiving any requests, because it will scale down to 0 for you. And then once you actually get traffic, let's say you don't have traffic for a while, and then someone goes to your goes to the URL of your application, Code Engine will cold start your application for you and scale up the number of instances that you need to meet the demand of the incoming requests that you're receiving. There we go. Okay. So before we get started, again, if you'd like to follow along, please sign up for an IBM Cloud account so that you can provision your service instances at ibm.biz/ce-sib-2-cloud. Okay, so you can sign up for IBM Cloud, and then you will need to create an IBM Cloud pay-as-you-go account. So have no fear, there is a free tier. So we are going to be using Code Engine's Always Free tier, which allows for up to 100,000 vCPU seconds per month, up to 200,000 gigabyte seconds per month, and can accept up to 100,000 incoming HTTP requests per month. So as you will see, we will stay well within the light tier. We will also be utilizing the light tier for event streams as well. My favorite use case for SiB Solutions, use case for Code Engine is SiB Solutions. I think it would be helpful too, before we start building our application, to get a little bit of background info about SiB Solutions, what they do, and kind of how what we're doing today is relevant to what it is that they do and in their actual solutions that they provide to their customers. So I just had a few slides here that I was going to share. If you'd like to.
Yeah, definitely. So if you show me the next slide, then I'll go from there, I guess. So our use case is around that possibly you have sometime ordered something online, or sometimes gotten anything delivered to you that wasn't exactly what you wanted, or maybe you didn't even get anything. And that's not a new problem, but it's an increasing problem today, that a lot of things are getting lost on the way somewhere, or damaged. And there is a lot of things that can go wrong in a warehouse. So if you go one more slide. And we are a bunch of technology and logistics nerds that formed a company around this, that trying to solve this with technology. Everything can be solved with technology, right? And well, the cooler technology, the better. And we set up to try to solve this problem, and we are using then video imagery live that we are recording, and both recording and storing, and then understanding what is happening live using AI, and then sending a big amount of data to our servers in the cloud. I don't know if you have a picture of that, Jenna, of the structure. Yeah. So here we serve the user a overlay over the graphics, what is happening, and we do that by using the event streams we are sending, or Kafka. We are sending a lot of data from the warehouses all the time to the cloud, to where we have our servers, or serverless servers, if I should say so, in the code engine. And there is our smart assistant. It does receive huge amount of messages every second from a lot of cameras. Imagine that in a warehouse, there are a bunch of stations where you want to have cameras. Each camera has like 10, 15 frames per second, some go 30, and it's sending that information that it gets there to our cloud, which is scaling depending on how much is happening in the warehouses, taking a fast decision on if things look good or bad, and then serving the operator with feedback if they should do something different. And that is all happening real time using these services. And we use a lot of other services at IBM as well, like MongoDB and Redis and so forth, like it says there. And we want to use all things open source while doing this. So that's one of the things that we've been very, should we say, religious about, that things should be open source based, so we don't have to build everything ourselves. And we get all of that from IBM, which is fantastic. So the event streams is Kafka. It's not a simulated Kafka, it's an actual Kafka. The code engine is actual Kubernetes, not the simulated one, or nothing strange about it. It's the actual stuff. And it just runs any Docker we want. So that is kind of where we got the use case for today, that we're going to show you. We're going to misuse Kafka a little bit, but we're going to show you how one can stream that. Was that about where we should land, Jenna? If you're talking, Jenna, you're muted.
Oops. Okay, sorry. Thank you. Okay, so we are going to be getting hands-on with event streams and Code Engine today, and highlighting a lot of the great features of Code Engine, why it's a great option for developers. I myself am a developer. I prefer to not have to fight with as little infrastructure as possible. Get things up quick, and literally one-click deploy things, which is always fantastic. So there's two things that you will need today. The first is the IBM Cloud account. the next is the GitHub repository. So I'm going to post those in the chat. And again, the repository is at github.com/jwritten/IBM-X-SIB. So the first thing I'm going to do here, okay, I am going to cloud.ibm.com and I'm going to log in. Okay. Probably will need to accept a security. There we go. Okay, so let me just log in here. I had to update everything today. So let me just log in here quickly. Okay, and then we can get situated. All right. Okay, so what I'm going to do is I'm going to walk you through how to get this set up on your end. And I will be using some instances that I've already set up, but I will walk you through how to provision everything. So the first thing that we're going to need to provision is an event streams service instance. So the first thing I'm going to do, let me just check what account I'm in. Let me go here. Perfect. Okay, so the first thing I'm going to do is search for event streams. Click on the event stream service. Okay. The default for the light tier is Dallas. So the default is set to the free light tier, and the location for that is Dallas. So I'm going to leave that. That's fine. I'm going to give my service instance a name. It should select the default resource group, which should just be default, unless you have some other resources groups that you've created. Click the license agreements and click create. Okay. Then there's a few things I want to show you here. So we have a few things here. We have a getting started guide. We have topics. We have service credentials. Let's go back here. Here we go. So as we mentioned before, we are going to create a Kafka topic, which is a named log that stores the records that we'll be creating so that they can be referenced in the order that they occurred relative to one another. So after records written to a topic, it can't be altered or deleted. Instead, it's going to remain in the topic for a pre-configured amount of time. So I'm going to click on topics here, and we will be able to determine what that pre-configured amount of time is. So I'm going to create a topic. I'm going to call it IBM SiB. Okay. I'll click next. We don't need to add more partitions. One is going to be just fine. And so here's what we're talking about, our message retention. So this is how long the messages are retained before they're deleted. And if our messages are not read by a consumer within the amount of time, they will be missed. So we have a day, a week, a month. You can designate matter of minutes, seconds, hours, days, weeks, and months. So a day is fine. We don't need more than that. So I can click create and create our topic. Down here. There we go. Okay. And once our topic has been created, the next thing we're going to do is need to create some service credentials in order to connect to our event streams topic that we've just created. So I'm going to click service credentials here. There we go. Okay, I'm going to click New Credential and give it a name. Okay, we don't need to change the role. The role is fine. We can leave it as manager. Click Add. Perfect. So I want to just take a quick peek at our service credentials here. As you can see, there's a whole lot of stuff in here. There's API key, there's API key description, API key name. There's a Kafka admin URL, an instance ID, our Kafka brokers. We'll take a look at that in just a minute. What we're going to need to focus on here is our user key value pair, our password key value pair, and our brokers. So I'm going to keep this window open. And the next thing I'm going to do is you're going to want to clone the repo. So let me just open up a new terminal here. Okay, here we go. Make it a little bigger. I think that's good. Okay. So the first thing I'm going to do is let me just make a directory. Just stick this in. Okay. So the first thing I'm going to do is I'm going to clone the repository. So I'm just going to copy this here, back to terminal. Okay. I'm going to cd into my repo. Okay. And then as you can see here, we have some stuff in here. This is a very simple Kafka Python application that does nothing, just to show you how to get an application up and running with event streams. What we're going to be focusing on is the stream video event streams. So I'm going to cd into that directory. Okay, and as you can see here, we have a Docker file. So this is going to allow me to run it both locally as well as create a, we can actually deploy to Code Engine two ways. We can deploy from our source code, from our repo with Code Engine source to image. Since we have a Docker file here, I can also create a Docker image, which I'm going to show you how to do. Push it to my Docker Hub registry, and then deploy to Code Engine from that container image. We have a make file, we have our consumer .py, and we have our producer.py files in here. And I think we'll get into a little deeper into the code once we get things up and running. So to get things going, initially what we need to do is, the first thing we need to do is add our service credentials. So actually, since let me go over here. I think this is where I want to be. Start from here. Okay. Make this a little bigger. Okay. Okay, so the first thing I'm going to need to do is add our environment variables. So the first thing I'm going to do is I'm going to type export username. I'm just setting environment variables so I can reference them in my application once I create my container image and run it locally. So what I'm going to do is I'm going to set my username to token. I can do here. And I'm getting this from, let me just make sure I have this open. There we go. So I'm getting this from my service credentials here. Okay, so as you can see, the username will be token. So I can do that here. Okay, and then the next thing I need to do is export my password. Let's copy that here. Export password here. Okay, and then the last part I'm going to do is I'm going to actually, let me just add this here. Add my broker. So if you look at your brokers here, oh, where'd it go? There we go. You can just select the first broker from your list. What you're going to need to make sure, though, is that you set your environment variable to brokers. I made this mistake. Brokers, and then let me just grab this here. And you can just add your first one. Mine's going to look a little different. So I'm using the demo one that we created earlier. Okay. Okay. So let's go back. Okay. So the next part we're going to do now is we're going to build our Docker image. And we can do that by running Docker build, and then a period, and then I'm going to give it a tag. I'm going to give the tag event consumer. Okay. I'm going to build my Docker image. And then once that's done building, I'm going to run the Docker image locally with Docker. So make sure you have Docker desktop running. I've made this mistake in the past where I'm like, I don't know what's happening. And Docker desktop either wasn't running or I wasn't logged in. So make sure that you are logged into your Docker desktop. So the next thing I'm going to do is I'm going to run the Docker image. And again, all of the commands that you need for running everything is in both the repository in the, I'll show you right here. As we go here, all of the commands are here, and you'll just put in your service credentials or your passwords. Everything is here. It's also in the slides as well. So however you prefer to work through documentation, I have options for you there. Okay, so the next thing we're going to do is we're going to run our Docker image. So let me just run this here. Okay, and we're listening on port 8080. So once this is done running, I have the URLs as well where you can, and it's in the documentation as well, where you can view your locally running application. So just give this a second to finish. Okay, so let me go to the browser here. Gives a second to get loaded. Should see a image of a cat. Oh, there we go. Oh, no, we have our live stream going. Okay, so yeah, so this is actually live streaming from Lund in Sweden. Oh, and there is the cat. There is the cat. So we promise you cats. We don't want you to be disappointed. Here is the cat. Look a little. So when you're running this application locally yourself, you can actually use your own webcam and I guess live stream, or just look at yourself if you're, you know, having that kind of a day. So we have our application. It's running as expected locally with Docker. Now, the next thing I'm going to do, there we go. View the application. Okay, so the next thing we're going to do here is we're going to push our image to Docker Hub. So let me shut this down. There we go. Now, just to show you here, here's my Docker desktop. Come on. Oh, sorry, it's on the wrong screen. Okay, so as you can see here, you have local and remote repositories. So I'm actually going to push this image to my remote repository. And as you can see here, I have some other container images that I've created and pushed to my repository, my Docker Hub repository from my computer. So I'm going to show you how to do that. Now we've already built our application. So the next thing we're going to want to do is we're going to want to tag our Docker image. So I'm going to run Docker tag event consumer. Oops, sorry, that's not what I wanted. Let's type this out. Docker tag event consumer. I spell it right. And then I have it at jwritten, which is my Docker Hub repository, event consumer, which is the tag that I created for my container image. And then I want the latest version. Okay, so now that I've created my Docker tag, I'm going to push the image to the my Docker Hub repository. So I'm going to just type Docker push jwritten event consumer latest. Ooh. So basically what you're doing is you're running Docker tag with the same tag that we created earlier, and we're just pointing to our repository this time. So our repository, our tag, and we want the latest version. And then we're going to Docker push to the same repository image that we have stored here. Okay, so I'm going to push this image. As you can see here, the layer already exists. So I already had a version of this in Docker Hub, and it just verified that. If I had any changes, we would have seen some updates. Since I don't have any changes to my application, it pushed it to latest, gave it a key right here. And as you can see here, when we look at Docker desktop, I think it just closed. It wants to cooperate. There we go. As you can see here, in my images, my container images, in my remote repository, I have my event consumer latest image. So here's my event consumer with the, this is the latest version. And I just updated it. Okay, close this. Okay. Now, oh, here we go. So this is what I wanted to show you. It's at the top here, not at the bottom. Usually outputs are at the bottom. This one's at the top. So this push, this Docker push is referring to the repository right here, docker.io, jwritten, that's my registry, and event consumer is my image. So I'm actually going to use this in just a second. So I'm going to keep this open. But when we are deploying to Code Engine, this is the URL we're going to use to point to the location of our container image. So the next step is going to be, we're going to deploy our app to Code Engine. So we've already done what we needed to do. We've tagged our image, pushed our image to Docker Hub. We have the location of our container image. So the first thing we're going to do, I'm going to go back here and I'll just open up a new tab so we keep this one open so that we can reference our credentials. Okay. So the next thing we are going to do is we are going to click. There's a few ways we can do this. We can type Code Engine here at the top to search for and find our Code Engine service. Also, if you look at your hamburger menu on the side, Code Engine is the third option here. And what we want to do is we want to create a Code Engine project. So I'm actually going to go hover over Code Engine. You can also pin it in your menu. And I'm going to click on projects, because the first thing we're going to need to do is create a Code Engine project. So this is going to allow us to create Code Engine applications and batch jobs or run any type of eventing. And it's all going to be contained within the same region within our project. So you're going to click Create. We're going to select Dallas. You can select any location that you would like. So if you want to keep things close to where your other workloads are already running or close to your physical location, the choice is completely up to you. We have regions globally in Asia Pacific, Europe, and North America. So I'm going to click Dallas because that's where I normally run everything. I'm going to give my project the name of IBM SiB. The resource group is just set to default since I don't have another one, and I will click Create. Now, since I already have a project that I created, I'm just going to click here. So the next thing I want to do is create an application. So I can do this one of two ways. I can actually create an application inside of my project here. Pretty simple. The other thing I can do is I can actually, if you had gone to the Code Engine console, you can actually get started right away. So if you come here, we have the quick starts with a container image or with source code. So what I'm actually going to do is I'm going to just do it from here just for fun. I'm going to take my container image location here. I'm going to plop it in here where we paste your own image reference, and I'm going to just click Start Creating. Okay. Now, we can create applications or batch jobs. Application is the default, but we can also run batch jobs, which run to completion and exit. I'm going to call my app IBM SiB. Oh, sorry, it needs to be lowercase. IBM SiB. There we go. Okay. So I'm going to select my project, my IBM SiB Dallas project, the one I just created. I have my container image. My registry access is public. I am storing this in a public repository. As you can see here, you can also change any which TCP port your code is listening to for incoming HTTP requests. So you can change this if you need. The default is 8080. There's also a user ID override. We don't need to worry about any of that. So we want this endpoint to be public because I'm going to be sharing it with you. And the first thing we're going to do is we're going to take a look at our runtime settings. So for this, as you're following along, you don't need to make any changes here except for requests. So our requests are just the maximum number of concurrent requests per instance. And we have a minimum number of instances set to 0, which allows for that auto scaling down to 0. And we're going to leave our max number of instances at 10, which is the default. So I'm going to change this max concurrency request to 2. So if you're following along at home, I would change that to 2. And then the only other thing we need to do here is we need to add our environment variables. So we're going to add our, just like we did a second ago. Let me open it up over here so it's not in the way. There we go. So our first environment variable name, as we had when we were running locally, we have a username, and the value is token. Okay. So the resulting definition environment variable is going to be username equals token. So I'm going to create that. The next one is password. So the environment variable name is going to be password, and then the value is going to be, let me just get my, there we go, password here. There we go. I'm going to add that. And then the lastly, I'm going to add the brokers, which again, make sure you're using an S, brokers plural. So then I'm just going to copy and paste this from over here, which again, you only need to use the first line of the brokers listed in your service credentials. Since I'm running a little bit heavier, so all of you can join along, I'm going to add them all here, and then I'm going to click create. So as you can see, with just a few pieces of information, I just gave it the container image reference pointing to my Docker repo. I changed the runtime settings to max concurrency, which is requests per instance, to 2. And then I added environment variables. And if we look here, you can actually see as well, we also, Code Engine also generated for us a Code Engine subdomain, a Code Engine app, IBM SiB environment variable, and a Code Engine domain, which is our US South Code Engine appdomain.cloud, right? So these were kind of thrown in for us. These are the 3 that I added: the username, password, and broker. As you can see here, it is deploying. We have our endpoint is going to be a public endpoint, and you can see the public URL here. And if you look at the overview here, we're still deploying here. So let me go here. Let me just take a peek here, because I am going to share with all of you so that you can check it out as well. Okay, so our revision is ready. Actually, I want to bring this one over. Okay, so I can click test application, application URL. Okay, and as you can see, we have our cats. So we've built a container image. So to back up a little bit, we've created an instance of event streams. We have created a new Kafka topic. We've created service credentials to connect to that topic. We have created our very own container image. We have built it and then pushed it up to our Docker Hub registries. We've run it locally. And then we've taken that container image that we built pushed to Docker Hub, and we've deployed it to Code Engine. The only other pieces of information we gave Code Engine was that we updated the number of concurrencies to max concurrencies to 2, and we added our service credentials for our event streams instance Kafka topic, so that we could use that. I want to go here. As you can see in the overview here, so if you click the overview tab, what we're looking at is the running instances of our revision. So as you can see here, we had a cold start. We didn't have any instances of our application running. And now we have 1 instance of our application running. So actually, if I were to open up another here, Once that's finished there, we should see that. We'll be able to see that this auto scale up to show our next instance. And if you look down here, we have configuration revisions as well. So for instance, we have one revision of our application. I can always edit this revision of our application. I can, let's say, deploy a version 2. I can change the runtime. So I can make this go a little smoother, give it some more memory, leave everything else the same. Let me save and create this. And while we're waiting for that, I'm going to come over here and share with all of you as well. So this is our stream. So as you can see, this is streaming live from Lund, Sweden. Go to our overview here. So as you can see, we have 0 revisions. This is the one I deployed a little earlier. So what I'm going to do is I'm going to start a new instance of our application. So if you click the test application in the top right and click application URL, it's going to take just a second. It is going to require a cold start because we have Code Engine has auto scaled down our application to 0. Okay, so this is, here we go. So we have our live stream here. Hello to Sweden. So this is live streaming here. Make our picture a little bigger. There we go. And I thought that maybe we could take a moment to, I don't know if you wanted to share your screen also, if maybe we wanted to take a moment to look at the producer and consumer in our Python Kafka application, and maybe talk a little bit more about what's going on in there. And I can go back here and I can let you share.
Yeah, I can do that. I will kill the stream now.
Okay.
For a moment. So let's see. I will show you a little bit more of the code that's running so you understand that what we're doing. And I will also want to see if there's any question while we're doing that. Let's see.
Yeah, if you have any questions, feel free to post them in the chat or in the ask a question, and we'll make sure that we get to them and answer them for you.
Let's see. There should be this one. Here you go.
Maybe zoom in a bunch.
Yeah. So
That's good.
I am looking into our repository, and we try to name these things very clearly from the Kafka vocabulary. So we have the consumer and we have the producer. What I've been running now on my end has been the producer, which have been sending the images over Kafka. Just so you know, on this, Kafka is not really built for this, for sending images. So therefore, I scaled them down a bit. It can do it. You can send pretty heavy images, but it's, well, Netflix does not run Kafka for streaming, I think. So it's not what it's built for, but you can do it. In any case, so this is the code for the producer. It's importing the needed dependencies. The important ones are OpenCV. There is a Kafka producer from Confluent. Confluent is the company that makes Kafka, or open source. It's open source, but there's a company behind it, which is Confluent. Certified to get the certificates correct, and And here you have the topic. As you saw when Jenna was creating her event stream, she named it like this. And that's kind of important that we have the correct name. And then we have the username, password, and the brokers. And here we have the or brokers with the brokers we were testing with from beginning. So you can ignore these. If you get them running, then nothing is going to work. And we run the program here. This is the main function of a Python program. So we print out we're publishing video, and then we go up and do this. A very simple thing here is opening up the Kafka producer. As you see, we're just giving it the arguments of the brokers and how we handle the security, the username and the password. And then we have this little thing here, which is telling Kafka that we would prefer it sends one message at a time. Kafka is, of course, built for handling huge amount of data. It's basically a fire hose. And it will buffer up and send in bursts. When we're streaming images, of course, we don't want that. So therefore, we are telling Kafka to actually send only one. And here we create a producer. And here, since this is Python, this is extremely compact. You can either open a video file, which was the cat that you saw before, or we can open the camera, which is, if you have multiple cameras on your system, well, you have to figure out which number it is. But in my case, it's 0, which is the general camera. And then we just, as long as we can do it, we read from the video file, we resize it to something small, encode it as JPEG, and send it. This is all that's needed. Then we wait a bit and do it again. There is this flush if we want to make sure that the producer has sent everything, but, well, you basically don't need to run that. It will send only one at a time. So this is the producer. As you see, this is very simple. Then the consumer, a little bit more complicated. This is what Jenna has been running. But we built it in such a way, we're using Flask for this, which is a Python package for very easy web servers. But we want to be able to run this for multiple users. So, and the problem there is, of course, in this case, that if we are all reading from the same Kafka stream, then I would get one picture, Jenna would get another picture, and somebody else would get the next picture in the stream. But we all want to be able to get the same picture. So therefore, when you come into the basic URL, the first thing we do is that we generate a random number, a random string, like you see here, and we redirect you to a URL using that random string, which is then the consumer group. A consumer group in Kafka is, well, everybody in a consumer group shares a pointer, a read pointer. So multiple workers can be working on the same consumer group, and they take then turns of getting messages, and they will not get the same message, two of them. But now we want to get around that, so we want to have unique consumer groups for everyone who's watching, and that we do here. And here is where it actually happens. So as you see, it's pretty simple again. We set up a Kafka consumer this time with basically the same way as before, the brokers, username, password. The only thing here is that we have a group ID, and it's the consumer group, to make sure we're in a unique group. And then we have some minor settings here that we always go for the last message when we start up a new group. So we don't have to watch everything from a day before. We can start in the beginning of it. As you saw when Jenna was setting up the event stream, she could choose how long time we would save messages. And if we put that to a week, we could see everything from the start of a week if we wanted to. But here we want the latest. And we want it to automatically commit when it's read everything. that would be the read pointer that it's committing. And then we subscribe to the topic. We can subscribe to multiple topics, but in this case, we only want one. And we open up a stream with a multi-part message, just serving up the images. So here is what happens basically. If it's first time, we send a little refresh. We want you to refresh your browser once every 5 minutes or so. And then we poll the consumer. We get a message. We just show the message. We know that the message is a JPEG since we made it a JPEG when we sent it. So we just push it out. And that's it. That's all that happens there. There is one more thing there, of course, which is the Docker file. And that is, of course, extremely simple, as you can see here. We use a base Python Docker image. We install the requirements, and we run 2 workers. That's why Jenna set the code engine to be the scale of 2, because it will be able to handle 2 streams per Docker image, or per instance, if you put it like that. So that is how everything works. Super clear, I hope.
Yes, thank you so much. I was gonna say, if you get the stream up on your end, I was gonna share the URL in the chat so people can open up the app on their end, and I can share and we can watch it scale over here.
Yeah, I will start a stream then.
Okay, cool. Okay, so let me share. Here we go. Okay, so in the chat, I just shared the deployed application URL. So go ahead and click on that application. He's going to set up the stream again on his end. And what we're going to be able to do is we're going to be able to watch that here. And what we want to look at here, is it right here? Oh, here we go, is our overview. Okay, so we're going to look at the overview. So right now we have 1 instance of our application. I'm going to open up a few more. So if you click the URL that I just added to the chat, feel free to click and open up the application in your browser. Take just a second to get it spun up. Oh, no, this isn't the right one. Sorry. Need my Firefox. There we go. There we go. Okay. And we can look at our application here. Take just a second. As you can see, so we're already starting to scale up. So I'm going to click on another, open up another one. There we go. So we should see Code Engine scale up our application in just a second. So if you click on the link and you start running an instance of the application, we will see that here as well. Okay. Another one. Give it just a second to scale up. Go. My there we go. So now we have 4 instances of our application. And as we mentioned, if we look at our runtime that we took a peek at again in the code, we've set our max concurrency, which is our request per instance, to 2. And we're allowing a max number of instances to 10. So if we come back and look at our overview here, as our application scaling up. Make sure to open the overheating computer. Okay, I just want to make sure I shared the right URL with all of you. So our stream here. I just want to triple check. I think I did. I just want to be sure. So, and as you can see here, if you look at the end of my URL, that is my unique instance there. So if we saw in the code, so that we can each have a unique instance. Okay. But if you click the this is my instance. Okay. So, but if you click there and open up an instance, sorry, let me get this down for a second. Okay, there we go. So here is our live stream, and I have a few instances running. Let's see how many we have now. There we go. Click over. The laptop sounds like it's about to take off into outer space. Okay, there we go. Okay, so it looks like we have 4 instances running, and as more instances of the application are running, so as more of you or anyone visiting the application spin up an instance of the application and get it running, we will see that number increase here. What I'm going to do now is I'm going to close. I'm going to get rid of these instances of the application that I have open, and we're going to watch it scale down. So I want to show you as well. There we go. Cloud Code Engine auto scales down to 0. There we go. There we go. There's that one. Take just a second. I think Chrome is killing my computer right now. Just have one more to close. There we go. Okay. And then also I want to make sure that in my that I have these other ones I have here closed. So as you can see here, we still have our stream running here. So I'm going to close this one too. Okay. And so as you can see too, I had 2 different applications running using the same event stream Kafka topic, using the same credentials. And I had instances of the application running within 2 separate Code Engine accounts and projects, which is really cool. Okay, so as you can see here, we've already scaled down to 2. Okay, so this is on this instance. I just closed these. So now let me take a look at my other instance I had open here. Okay. So it looks like, oh, 6. Okay, cool. So we got more people connecting to the app. Very cool. So you see it scale up here. I'm going to come over here. And so I've killed off the last instance of the application I have running here. Yeah. Oh, maybe not. Okay. Over here. Oh, we can't go back. Okay. So with all of the instances of our application, once the application is no longer receiving any requests, like we saw just a second ago, is it here? I don't know what that was. Maybe that was making my computer slow. So as you can see here, so it's already scaling down. Ah, there we go. So we went from running 2 instances to running 1 instance, and now it has actually auto scaled down to 0. So even though I'm using the same Kafka streams topic here, this instance of this application, this isn't the one that I shared with you all. This is the instance I shared with you all. And as you can see here too, this has auto scaled down to 0 as well. So in less than a minute, we've scaled down to 0 as we're not receiving any more traffic to our application, which means we're not paying to provisioning for traffic that we're not receiving. So you're not incurring any costs until your application is running and receiving incoming HTTP requests. Let me go back here. And okay. So I would like to firstly say, great job to all of you. Some simple things, some advanced topics, a lot of moving parts, but kudos to all of you for sticking with it and making it through to the end. If you were just watching today, no worries. You can always work through. You can always work through the workshop and the information at a later date. We'll probably be building on this in the near future. This was the very first version of this workshop and the first time running the content. So thank you all so much for your patience and your participation. If you would be so kind to please fill out a very brief, does not require you to enter any personal information survey. I'd like to, I look at the feedback, I'd like to see what IBM cloud integrations would you want to see integrated with Code Engine applications, what tech stacks you would like to see sample applications and demos in. Feel free to share what it is that you're working with so that I can get a better idea of exactly what it is that all of you would like to see. Again, the survey is at ibm.biz/ce-sib-2-survey, and it is in the chat. And if you were not able to make part 1 or you would like to reference back to it, there we go. You can access the live stream recording at the same URL you joined with today, or if you are watching on an IBM Developer Social, you can access yesterday's part 1 of the workshop, which was a real deep dive into SiB Solutions as a company, how they're solving global logistics issues for their clients, how they're utilizing IBM Cloud technologies and particularly Code Engine, and getting more in depth. You can access the live stream recording at crowdcast.io/e/IBM-CE-SIB/1. So that should say 1. That is part 1. Part 1 of the workshop. As always, I have shared in the chat as well. If you would like to stay connected with us, feel free to reach out on LinkedIn with any questions. As always, I have all of the event resources here for you as well. Also, the IBM Cloud certifications. and all of our IBM developer social media channels. So again, if you have any questions, feel free to reach out to me. Feel free to reach out to SiB Solutions as well. We're available. You can send messages over LinkedIn or wherever you're comfortable. We'll happy to answer any questions. What's this? There we go. I would like to thank all of you for coming. I would like to especially thank SiB Solutions for all of their help, all of their hard work, all of their contributions today. I'd like to wish you all a very happy HACKTOBERFEST. Make sure you check out DigitalOcean HACKTOBERFEST challenge for this month so you can get your contributions in, win some cool swag. Also check out IBM's demo day coming up next week. And as always, I will see you all next time. I hope you have a wonderful weekend. And I'm sure I will see you all very soon on the other side. So thank you so much for coming, and I will see you all next time.
It's so exciting watching my life unfurl at a time when geeks like me can change the world. There's a hackathon tonight, and if it works out alright, I can improve society. Oh yeah, improve society. But BT will be there with money in his wallet. If I pitch him like a boss, I could get funding for my project. 7-figure summit, I'll be crushing everyone at the hackathon tonight. At the hackathon tonight. There are prizes up for